Welcome back. So now that we've followed the happy path of Power Pivot Table development and explored a few examples where things just worked, it's time to deepen our understanding by digging into some of the pitfalls and limitations of building pivot tables from the Excel data model. It turns out that in real-world modeling scenarios, you need to carefully consider the relationships between your tables before you start happily hacking away at your pivot tables. So let's see why. Now here I've got a blank pivot table that's pointing to our data model, and what I'm going to try to do is summarize the count of customer orders by product name. So first I'll find my orders table in my fields list, and then I'll just drag sales order ID down to my values area, and then summarize it by count. Next, I'll locate my products table, and then drag in product name in the rows area. And right away, this looks extremely scary and confusing. We're getting the exact same count of our sales orders for every single one of our products. Now, of course, we know this can't be right, and incidentally, this grand total number we're getting is the same as the grand total count for the entire table. And if we roll down to the bottom of the pivot, we'll see that the grand total, 30,500, is the same number we're getting for each individual product. So this obviously can't be right, but why? Well, let's go to the diagram view of our data model to find out. So looking at our products table and our orders table, which are the two tables that we included fields from in our pivot table, we see that there is no relationship between them. And as a result, applying a filter from the products table doesn't do anything at all. That's why every single row in our pivot table returned the grand total. Since there's no relationship between the products and orders table, that means those filters that would otherwise be applied in our pivot table, those being the names of the individual products, had no effect. And what happens when you compute a count of records in a table without any filters? Well, you just get the number of records in the table, which is exactly what we saw in every row of the pivot table. But wait, you might be saying. In our example from a couple videos back, we were able to successfully apply filters from the regions table and the states table, even though there was no direct relationship between those tables and the orders table. So just to briefly recap, here's the pivot table from that example, and if I just expand our field here, we see that we have region and state on rows, and then we're computing a count of sales orders and sale order detail IDs, which is basically the count of the items in the orders, in our values area. So connecting this back to our data model, we are in fact pulling in fields from the regions table and the states table, and we're using those to apply filters to calculations that we're applying to the orders table and the order details table. So why did this work, but applying filters from the products table to the orders table did not? Well, the difference is, while there is no direct relationship between either the regions table or the states table and the orders table, there is an indirect relationship via intermediate related tables. So our states table is connected to the orders table through customers, and our regions table is connected to the orders table through states and customers. But then you might say, well, our orders table and our products table are both connected to the order details table. So aren't they also connected in this indirect way? Well, in a sense, yes, and it's true that we could, in a single pivot table, apply filters to the order details table from both the products table and the orders table. But we can't apply a filter from the products table to the orders table. The rule of thumb is, when considering what filters you can or can't apply to a table, simply follow the chain of one-to-many, or in rarer cases, one-to-one, relationships extending from that table. Any table that is part of that chain can be used as a filter for any table lower in the chain. Similar to how we referred to relationships flowing downhill, this is commonly referred to as filters flowing downhill. Although again, in our case, it looks more like flowing from left to right. Now, while the products table is in fact connected to the orders table indirectly through the order details table, the connection is not of a one-to-many nature. Instead, there can be many of the same sales order IDs and many of the same product IDs in our order details table. So instead of a one-to-many relationship between these tables, the relationship is actually what's known as a many-to-many relationship, which is allowed in some paradigms like SQL databases, but not in the Excel data model. If you think about it, even a lookup table like regions that's not directly connected to the orders table still essentially has a one-to-many relationship with it, since a region could have many orders, but an order would never be associated with more than one region. So the bottom line is, your filter fields should be on the one side of the relationship with the table being filtered, either directly or indirectly via a chain of one-to-many relationships. So just to drive this point home, I'm going to iterate through all the tables of our little data model here and explain which other tables they can and can't apply filters to and why. Now, starting with our table all the way over on the right, the order details table. This table is at the bottom of the chain of one-to-many relationships, so to speak, so it can't apply filters to any other table. You can think of this table as the ultimate filter E. All the other tables in the relationship can apply filters to it, but it can't apply filters to any other table. Then moving over to our products table. Our products table has a one-to-many relationship with the order details table, so it can apply filters to that, but it can't apply filters to any other table in our data model. That's why when we tried to pivot our order counts by product name earlier, our pivot table looked so wonky. Now our orders table can also apply filters to just our order details table. Now moving left, our dates table can apply filters to the orders table directly and also through the orders table to the order details table via that indirect one-to-many relationship. Similarly, our customers table can also apply filters to both the orders table and the order details table through a direct and an indirect one-to-many relationship respectively. But again, similar to our products and orders tables, we can't use the dates table to filter the customers table or vice versa. And at this point, I suspect you're seeing the pattern. Our states table can filter the customers table, the orders table, and the order details table, and then our regions table, sitting all the way over there at the left, can filter anything downhill from it in that chain of one-to-many relationships, from states to customers to orders to order details. All right, so clearly, while creating business intelligence with Power Pivot tables and the Excel data model is incredibly powerful and relatively straightforward, it also requires more careful thought and deeper understanding of your data than you might have expected based on your experience with conventional pivot tables. Up next, we'll examine another important nuance you're likely to encounter in the real world: multiple data tables representing entirely distinct business processes that you would like to analyze in the same pivot table. I'll see you then.